we go. Still some way to go, but RF and AM sections are working. First time this thing has spoken for many years. I don't have a decent antenna or anything hooked up yet. But hey, we're getting there.
Voilà, ce qui veut dire je ne retrouve plus mon bagage. Et la réponse c'était ne vous inquiétez pas, nous allons vous aider à les retrouver. Voilà, c'est tout pour aujourd'hui. Au niveau des cours, on se réécoute les dialogues en intégralité.
So I found this excellent document thanks to the colleagues on the UK Vintage Radio Forum, which goes through three main different options for droppers. This one right here is what I have at the moment, which is a simple resistive dropper. And the problem is heat dissipation. So I'm going to need some massive heatsink solution for this to work. And so at the moment that looks impractical. So then it goes through various calculations. Then it goes on to a combination of dropper resistor and diode. Again with worked examples and calculations and all the theory of how all this stuff works. As a worked example. And then finally we come to the capacitive dropper. And so this is the one I'm going to have a go at. And again, it goes through all the theory of how this works and gives worked examples. And so this circuit right here is the one that I'm going to have a go at. So you need a dropper capacitor with a shunt resistor so that it discharges when you switch off, a surge limit resistor, and then your load. And as you can see, it shows all the math, how you calculate all this, and then it gives the pros and cons of each design. And last but not least, which is very helpful, it talks about a spreadsheet tool that is available that lets you calculate all the values pretty straightforward and relatively easily. So here is that spreadsheet tool. See if I can zoom in on it a bit closer. So here is that spreadsheet tool. And so as you can see, if I pop in the value here, so for the moment I'll stick with the supply volts of 120. I've got 50 Hz frequency here. My heater voltage, which I've measured, is 70 volts. Heater current is 300 milliamps, and you can specify the voltage drop in the surge limiter, and the default is 10 volts, so I left it like that. And so over here you can then see on the right that the dropper cap value is 10.68 microfarads, the surge limit resistor is 33 ohms at 3 watts. And so since all this is very theoretical, I've decided I'll make this up, if you like, in prototype form, and then we'll test it out and see, and depending on how all that goes, we'll decide where to go from there. So let's see what this looks like in practice. So three fairly straightforward components. The main one is obviously the capacitor, and this is a motor run capacitor. As I guess you guys will know, you have motor start caps and motor run caps. You need motor run caps because they're designed to stay in circuit all the time, versus the start caps, which are only designed to be in circuit during the startup. Then I have I got a 5 watt surge limit resistor and 100k shunt resistor to discharge. As you can see, all that stuff will fit quite neatly into the can that I have from the electrolytics. However, before I go doing all that up, I'm gonna basically put this together in what I call a prototype form, check it all out and see how that works, and if it works then yeah, we'll put it all into the can and put it back together. I did get some alternative values of shunt resistor, and I also got a 12 microfarad motor run cap, because that's actually the largest value that will fit in my can here. So that's plan B in case I need it, but hopefully prototyping all this stuff up, connecting it up to the Radialva, will be in business and I can move on to other parts of the restoration. Okay, here's the prototype setup with the cap over here and the resistors and so on, and I'm measuring on here the supply voltage to the heater chain, which is on here, and I just have the AVO standing by to have a look at the B plus and whatever. So I powered this up before I hooked up the video because I was a tad nervous to do that with video going at the same time. I wanted to devote my full attention to making sure nothing went bang. Okay, so you can maybe see that my calculated voltage, my actual voltage, is a tad lower than what the calculation was saying. So therefore there's another variable in here, so the current consumption through the heater chain must be a bit different than I assumed. So I'll have to go look at that. However, this is a station coming from the Netherlands, so so the thing works, and B plus sits at around just below 90 volts versus the target of 105. So at the moment voltages look just generally a little bit low. I don't know how serious it is, so I'm gonna quickly look up as to why my heater chain volts that I'm measuring are a little bit lower than the calculation before I go doing anything permanent with this. But yeah, step forward, and the capacitor wrapper does seem to work, and there's no heat of any significance being generated, so definitely the way forward. So at this stage the capacitive dropper is now fitted into the electrolytic can here. I did drill some very tiny little ventilation holes on the bottom on that side, the top on this side, which you're not really going to see when the thing is put all back in its cab, because the dropper resistor, the surge limit resistor, which is fixed to the can in here, does heat a little bit, and so I wanted to use all this metal to dissipate the heat. Progress being made, and I'll decide later if I want to modify the dropper so that I get it to I can actually plug it directly into my local main supply here. But for the moment it seems to be doing okay, so I'll have to get on to some of the other mechanics. So the dial cord in the center section here starts slipping like crazy, and that's going to be quite a bit of a task, because the way it's designed is the entire dial cord mechanisms with all these little things that move around are all fixed to this plate, with the exception of the big main pulley, this guy right here, which of course is fixed to the tuning cap. Now conveniently there is a hole right here, so I'm assuming that the way this is done in the factory is there's like a little tool that you would use to mount the big pulley onto the front panel, so you can do the whole dial cord mechanism with the thing off, and then you fit the whole panel onto the chassis, and then the shaft of the tuning cap gradually pushes through to take over this pulley here, and then the little tool just pops out. So whether or not I'm going to be brave enough to try and replicate all of that, don't know. But yes, so some progress being made, and so I'll ponder over how to do the dial cord. So I had to start it on the cab to just clean it up a bit and give it a little bit of a shine, and it seems to be coming up okay. I have to do all the painting in the grooves here, so I have to do a little bit of work on exactly what paint that should be and how all that's going to work. However, the big challenge for all you guys out there is going to be my dial plate here, the glass dial. Unfortunately, most of the station names on here are printed in white, and so I guess, as you guys know, the decal process doesn't really work because, well, printers don't print white. They can print pretty much any other color, but not white. So I've got a scan of the dial thanks to a colleague who has a similar model. And I just have to try and figure out how am I gonna replicate one of these guys. All suggestions welcome. Okay, so I think next will be putting it all back together. Yeah, I have to. These rubber mounts for the glass dial are also all weathered and hardened. And so when you clamp the dial down, it's loose. There's no shock absorption or anything from these, so I'll have to replace these guys, because you can hear they're kind of like hard as metal instead of being soft and absorbent. So we'll get to that as well. So definite progress being made here. Nobody more surprised than me.